Hello, and thank you for joining this ICARUS presentation. My name is Katrina Dupuer, and I'm a senior engineer with Research Driven Solutions, and we're an engineering consultancy based in Dublin, Ireland. The topic that I will be presenting today is climate change and how it impacts our road infrastructure. ICARUS is a Cedar-funded project with the primary objective of improving the uptake of climate change adaptation in the decision-making processes of road authorities. In this project, we follow 6 stages towards implementation of climate change adaptation. These stages are framing, where we assess where we are now, the business as usual stage, where we review how we do things now. Then we propose adaptation options, which are measures we could implement. We have the decision case for adaptation, which is where we make decisions on what to do next. Then we have the implementation strategy stage, where we implement what we've decided to do in the previous stage. And finally, the monitoring and evaluation stage, where we review what we have done. This short video will focus on the first stage, framing the problem and looking at where we are now. In this video, we're going to look at what climate change is and how it is affecting our road infrastructure. We will look at how to identify climate impact drivers, or CIDs, relevant to your jurisdiction or organisation. And finally, we will explain the importance of climate change adaptation. So what is climate change? Well, most of us are familiar with the concept of climate change now. And basically, it's the overall increase of the greenhouse effect as shown in the diagram on the slide here. The Earth absorbs solar radiation as part of its natural warming process. Part of this radiation is reflected back to space by atmosphere, oceans, lakes, or ice. But before leaving to space, part of the long-wave or infrared radiation is absorbed by clouds and greenhouse gases in the atmosphere and reflected back towards Earth. This represents more steam accumulation in the atmosphere, which is causing more precipitation on Earth. The problem emerges in this phase because in the last 150 years, the concentration of greenhouse gases has increased, causing more radiation to reflect back to Earth, increasing the global average temperature. And the rise in global temperature has a number of effects on the climate system, known as climate change. Climate change scenarios are projections of how the climate might change in the future depending on the societal choices made, policies committed to, and resulting climate effects, and these are mainly greenhouse gases in concentrations in the atmosphere. Climate scenarios are created using global climate models, or GCMs, which use mathematical equations to replicate the physics of the Earth's systems. Different levels of greenhouse gases and other climate drivers are added into the global climate model to output various scenarios of the Earth's climate. It is important to note that although we try, we cannot predict the future, and so these are possible evolutions of the climate system depending on a high number of variables. This is an example of a climate model with varying levels of greenhouse gas concentrations as developed using data from the Horizon 2020 Crescendo project. Shared socioeconomic pathways, or SSP projections, are combined with representative concentration pathways, or CPs, to create the most likely future scenarios based on economic, policy, and environmental data. Climate change scenarios may then be developed based on these projections. While the impacts of climate change on European roads are impossible to predict accurately, but different organisations have already started research initiatives such as the Adaptation to Climate Change Task Group under CEDAR. According to their evaluations, some of the foreseeable impacts are more flooding and erosion, landslides and avalanches, or droughts and high summer temperatures, higher risk of wildfires, further deterioration of roads and pavements, and heavier snowfall. While impacts may directly affect a road asset, many impacts may occur to a combination of assets. For example, an inability to effectively drain roads in a storm event could have knock-on effects on pavements and structures that may be immediate, such as inundation of the road, reduced skid resistance, damaged road gantries, or delayed impacts such as subsequent freeze-thaw action on the pavement, or delayed or cumulative damage to earthworks. Climatic impact drivers, or CIDs, are physical climate system conditions, for example, means, events, or extremes, that affect an element of society or ecosystems. The CID framework includes 7 categories with 33 climate factors, and each factor can be assessed using different evaluation indices for different affected sectors. Please pause the video here to take a moment to review the climatic impact drivers that we have used in the Icarus project. Let's look at an example of a future climate scenario. Here is how mean air temperature might change over the next 100 years based on European climate databases from the European Environment Agency. A warming of the temperature will increase the heat island effect, and as a consequence, several impacts may occur, such as melting asphalt, asphalt rotting increase due to material constraints, thermal expansion on bridge expansion joints, and paved surfaces. This warming trend could require modification in road pavement design and maintenance, changing, for instance, asphalt properties and updating construction and maintenance standards. So, what is climate change adaptation and why is it important? Climate change adaptation measures are possible solutions to help reduce the impact of climate change on our road infrastructure. It is really important to implement climate change adaptation in order to increase the resilience of our road infrastructure to climate change events and also to increase the infrastructure availability and reliability. So thank you for watching our video. I hope it has helped you to understand climate change and how it impacts our road infrastructure a little better. Please go to the Icarus website by following the link below or scanning the QR code to find out more information in relation to this project. You can find all our deliverables, including deliverable 1.1, which has more information on this topic under the resources section of the website. Thank you.